Skal man tro IPCC's egne computermodeller, vil jorden stadig blive varmere, og naturkatastrofer vil blive hyppigere, hvis ikke vi begrænser udledning af CO2 drastisk. Men hvordan matcher disse computermodeller med de virkelige observationer? Det og meget andet snakker jeg med professor John Christy om. Professor John Christy fra Universitetet i Alabama, USA, står for at indsamle og analysere de data, der kommer fra vejrballoner og satellitter, som danner grundlag for de globale temperaturserier. Velkommen indenfor. Professor John Christy, thank you for joining me. Pleasure to meet you.
It's a pleasure to be here.
Thank you. Can you please tell me a little about your background and who you are?
Okay, I was actually born and raised in California, the other side of the United States, in a desert area, Fresno County. I went to school as a math major and then later as an atmospheric science major and received a PhD in atmospheric sciences from the University of Illinois. And I've been here ever since I graduated, 35 years at the University of Alabama in Huntsville.
So you're a researcher, are you teaching, or you do both?
I do both research and teaching. Primarily, though, research is what I spend most of my time on.
Oh, okay. It's like a field research, or you viewing data, or?
My research is mostly on data analysis in terms of trying to build climate data sets from scratch so that we can have a record of how they were built and what they actually mean.
I see. You've been involved with the measurement of the climate, so to speak, the measurement of temperature and water vapor in the air and so forth, and you've actually been one of the pioneers in doing so. Can you tell me a little bit about how it all started and how it evolved until nowadays satellite data?
All right. Around 1988 or so, there was a lot of information coming out stating that the globe was warming rapidly, and congressional hearings were held. But we knew that those data were based upon ground stations which were pretty sparse and not very well calibrated. And my colleague Roy Spencer was a satellite expert, and we were able to take data from NOAA satellites that orbit the Earth from pole to pole, so they see the entire Earth, and take a deep layer of the atmosphere and get the temperature of that. Rather than something just right at the surface, we actually were able to measure the temperature of the entire troposphere from the surface to about 10 kilometers in altitude. And that's a bulk of the atmosphere. So if you know the temperature of that, you will know if there really is a change in what's going on. And so we began that study in 1989 and published it in 1990, and is still carrying on with the satellites today. Oh,
so your work with Roy Spencer, are you still colleagues, or you work together? Or how does it play out?
Yes, I'm the director of the Earth System Science Center here at the University of Alabama in Huntsville. And Roy is one of my chief scientists, so we work together right here in the same building.
Oh, so you collect data from the satellite, but you also use weather balloons. Is that still a thing with weather balloons now we have the satellite?
Oh, weather balloons can do something satellites can't. One thing weather balloons do is take precise temperature and humidity and wind at very discrete levels. Satellites see big layers, and so if you want to get the fine resolution in the vertical, you do need balloons. So we will continue to have balloon data.
Oh, so how does it work with balloons in practical? How often are they released, and how big a network do you have for people who release it every day?
Well, of course, balloons are only released where people live, and so that's going to be at best a few islands out in the oceans and various places on the continents. The United States and Europe and China have lots of balloon data, but most of the rest of the continents do not. So we do have kind of a sparse network of balloons, and that's a little problem. So what we do in comparing with satellites is we take what the satellite sees at that same point where the balloon was released. And so we're able to do a real direct comparison between the two.
How long does the data go back for the balloons? Are they the same as satellite?
The satellites start in late 1978. The balloons go back about 20 years earlier, about 1957 or so, for enough coverage to where you have some sense of a global temperature.
So would you say that the land-based weather stations is not really a good data set to conclude anything about the climate or like the trends, or are they useful for us in some extent?
In terms of climate for long-term changes, the surface data set has a lot of problems. The chief problem is that much of the major continents are not observed. There were only a few stations in Africa and in South America, and these are big continents, and lots of Asia in the early part of the 19th century, so you don't have much information there to make a temperature measurement for the globe.
No. So the satellite doesn't really come to play until like the 1980s or so, that area. Does that mean that we cannot really trust the data from prior that period?
Well, a lot of people try to work out the problems of the surface data set, and so we have some reasonable results from what they show. I believe that they probably exaggerate the warming over land because of the fact that the weather stations are established where people live. And over the last 150 years, people have created roads and parking lots and buildings and so on, and those affect the surface temperature measurements by warming them up a bit.
So in the last like 100 and 150 years, the globe had been warming around 1 degree Celsius. Could that be less than that?
I think it could be less than that, but not too much, maybe a quarter degree less than that.
So you can still use the data for some extent.
Yes, I think what you see in the surface temperature data set is a very clear rise from 1910 or so to about 1940, 1945, and then a leveling off until about 1970, 75, and then a rise since that time. And that's probably a pretty good representation of what actually happened on the global climate.
With some degree of uncertainty, I guess.
Some degree of uncertainty, and the big uncertainty, you know, I like to build data sets to study the climate, and that tells us what the climate has done. The real big question is, why did it do it? So you can ask the question, why did the Earth warm from 1910 to 1945? It certainly wasn't due to humans.
No.
And so we would indicate that I like to say Mother Nature. That Mother Nature or natural variability can cause the global temperature to change.
That happened a bit in the past before, I guess. Do we have now the coverage of the world to like, as I know it, the satellite data doesn't include the Arctic region, is that correct?
The satellite data we use to have a good enough and dense coverage for the polar regions extends to about 85 north and 85 south. So that's a very tiny bit of the polar cap that is not measured well enough, and so we don't include that. But 99% of the globe we have.
Oh. Is the coverage enough to get an accurate idea of what's going on, or would you like more satellites, or how?
Well, we can always use more satellites, mainly so that we can intercalibrate between them. But you can imagine the satellite orbits pole to pole as the Earth rotates underneath it. And so the satellite, it has about 14 orbits per day that it sees everywhere around the Earth. So it sees very systematically. This is one of the best things about satellites, is it uses one thermometer and it measures the globe systematically every day. And so we get a nice geographical coverage and not have to worry about the fact, like in surface temperature measurements, you might have a spot here, a spot there, and then the station goes away and another one comes in or gets moved. and so on. We don't have those issues with the satellite data.
No. But I've been reading about like satellite, when you launch them, they have to be calibrated once in a while. But I guess does that give some like place to error in the measurement, or are they very accurate?
Most, generally any data set is going to have some error. What we do is we can calibrate one satellite against another or against two others if there are three up there at the same time, so we can tell which one might be off. And that has actually helped us discover the types of drifts that occur in the satellite data, and we're able to correct for those. So we put our error range at plus or minus 0.05 degrees C per decade. So over the last 4 decades, that would be a change in temperature we know within 0.2 of a degree.
Oh.
And the change hasn't been much in the last 40 years.
What you interesting about is the trend, I guess, not the actual measurement for each day, I believe.
Yeah, the change over time is what people are really concerned about.
Yeah.
We can say the average temperature of the layer from 0 to 10,000 feet is about 260 Kelvin, about minus 13 Celsius, but that doesn't mean a lot to people.
No.
When you say, oh, it changed by 1 degree from 40 years ago to today, well, that means something.
People can relate to that. The policies about the climate, especially in the western part of the world, is actually hung up on IPCC's climate models. How well does those fit to the observations that you use, that you see every day?
Well, and the short answer is not very well. And we have tested many of these models through the years, and we've really zeroed in on a part of the atmosphere that is very critical, and that's the tropical atmosphere up around 8 to 10 kilometers or so. Because in that layer is where the Earth releases a tremendous amount of heat. So you can think of it like a vent that opens and releases heat and closes, and it keeps the heat in. And what we found with climate models is that they put a lot of water vapor and high clouds there that act to close the vent. When we look at the satellite data, it allows heat to escape much more readily than models do. So the models retain that heat, they keep the heat in, sort of like closing that vent, and therefore the Earth warms up faster than it should be. And when we compare the temperature of that layer with the actual measurements, the models tend to warm 2 to 3 times too rapidly. And that's a huge error to overcome.
Is that by any means scientific accurate, or do you see as that you have to redo or remodel that climate model they're using?
Right. We have published these results. Other people have published the same results, that the climate models are just warming way too rapidly in the tropical atmosphere. And so one thing to do would be for models to figure out how to keep the humidity, the water vapor up there, from getting so moist, because that's what the models are doing. They're making that level too moist, and that acts like a blanket or closing the vent, in other words. So if you remove that water vapor to some extent, it will allow the heat to escape to space. And here's just one little calculation we did, was that in the real world, when the Earth temperature warms up 1 degree, you have about 2.6 watts of energy leaving. So the atmospheric temperature warms up 1 degree, and the atmosphere sheds 2.6 watts. The same calculation from the climate models showed 1.4 watts. In other words, when the climate models warm up the atmosphere, they don't release as much heat. And so that heat is retained in the system and causes that extra warming that we see in the climate models. And for policy, as you mentioned earlier, that's just shouldn't be the case, because climate models should not be used for policy if they cannot model the system correctly.
And I guess that's the whole problem. So in your mind, why is it they are so wrong? What are they doing wrong You told about they exaggerated the water vapor, but what is fundamentally wrong with them?
Well, I think most of them, and I don't know exactly how this works in the climate models, require the humidity, the percentage of moisture to be constant. So that if you warm up the atmosphere a little bit, you increase the amount of water vapors there to keep the humidity, say, 50%, to keep it constant. Well, warmer air holds a lot more water vapor than cold air. And so if you increase the temperature a little bit, that means you have to increase the water vapor, which means you're closing the vent, which means you increase the temperature more, which means you increase the water vapor more, which means you close the vent more, and it's a vicious cycle. And you see this extra warming then occurring. That's one half of the problem. The other half of the problem is that then these climate models are promoted as telling us the truth about what the future is going to be. And if I were just to sum up in a very simple statement, I can say this: the climate models don't agree with what has happened in the past, and they don't agree with each other about what's going to happen in the future. So why would you use them for policy?
That's the very good question. The climate, the policies, is built upon this theory that when you rise CO2, you warm the climate a little bit, atmosphere, and then the water vapor will start to increase in the atmosphere, and that will trap even more heat, and that's gonna make a warming spiral. Has that ever happened in the history? I guess CO2 has risen before, and in the history of the Earth. So,
well, that's a good point. Is that if you look at the long history of the Earth system, say for example, when corals evolved about 60 million years ago or so, the Earth had 4 times as much CO2 as it does now. So in terms of life on the planet, CO2 is food. It's wonderful for life. If we put more CO2 in the atmosphere, the biological world would love it. And in fact, I was talking to some folks in the farming industry, and they are creating fertilizers and so on to increase yield, and they are able now to increase the yield of crops to the limit of what CO2 is in the atmosphere. And they just can't increase them anymore because there needs to be more CO2 for the plant to grow even better.
So, and plants evolved at a much higher level of CO2. So it's no wonder why they are so happy when we increase it a little bit. So you don't see the current level of CO2, the rising of the CO2, where they come from as a problem climate-wise.
That's right. I don't see that the cost of rising CO2 concentrations is that important. It's certainly the plant world loves it. And then you could also say there's something else that's involved here, and that is, what does that CO2 represent? That rising CO2 represents the fact people are living longer and better lives. And so that's a benefit, a huge benefit, that carbon energy has allowed people's lifespans and the quality of their life to increase dramatically in the last 100 years. At the same time, because of our wealth, we've been able to mitigate the damages and the deaths from climate events. You might have seen some of the charts that show deaths from climate events are down 95% in the past 100 years because we are wealthier and use energy to protect ourselves from the climate variation.
And I guess 1 degree warmer climate will only benefit this growth, because it's easier to grow crops when it's warm than when it's cold, I guess.
Yes, when you do a full accounting of the benefits of extra CO2, you will find that you end up with a positive, that if you put more CO2 in the atmosphere, that actually makes the living standards of people rise even more, and the biological world advance even more.
But is there a threshold, so to speak? Like, let's say, I don't know, its CO2 level have been rising like 100 parts per million over the last 100 years or so. It doesn't seem like that extreme or so, but could it, in theory, trigger some kind of rapid warming. If we release a huge amount of CO2 by burning all the fossil fuels or whatever, could it do some damage, if you will?
Well, there are a lot of scary stories out there about if we reach some kind of tipping point. But it turns out that the way carbon dioxide acts in terms of a radiative gas, the amount of energy it absorbs and so on, decreases in terms of its incremental effect as more CO2 increases. So if you double CO2, there is one effect. If you double it again, that effect is less than half of what the first doubling was. So you have this approaching a limit of no more impact in terms of the climate with extra CO2. And these amounts of CO2 will always be below any kind of threshold that would be cause it to be a pollution or problem. In fact, you can go into a lecture hall sometimes and take a CO2 monitor and you will find it's 1,000 parts per million. So 1,000 parts per million is not a problem for
do we know the threshold for where CO2 doesn't really do anything more, or is it still debatable?
That is debatable because of how these feedbacks work that I talked about. Because some people think that the feedbacks will always be positive, like adding extra water vapor, making the temperature go up and up. That's a positive feedback. That we just don't know enough about how those feedbacks will happen, but we can look at the past and see that they happen very gradually, and that the atmosphere has negative feedbacks too, that the atmosphere has ways to shed that extra heat, and so that keeps the planet from shooting off into some kind of warm
I
world.
guess a lot of that water vapor will go into clouds and rain back, that cooling too. We have been trying to determine the sensitivity, the climate sensitivity of CO2 for decades. Are we close to find a current answer?
That's a very sore point among climate modelers, as you probably know, is that through the years, that range of the climate sensitivity, whether if you double CO2, will it warm up 1.5 degrees or 4.5? That's kind of in the range. And the latest models show an even wider range, going up to 5.6. So the answer from the scientific community is we don't know what's going on, because every time we have a new model, we get a completely different result. And right now they vary over a factor of 3, which is a huge error range for any kind of science, a factor of 3. Our calculations with real data, with empirical data, where we know how much extra forcing was put on the climate system and then what the temperature response is over the past several decades, we get a number right at the bottom of that range, about 1.5, 1.6, 1.7. Which has very little impact in terms of climate events on the planet.
So if CO2 is not the dominant factor in the climate system, what is? Do we know? What is the dominant factor? What?
Well, if you're talking about dominant factors on many time scales, on say a year or two time scales, we know what that is. That would be volcanic eruptions or El Nino, La Nina, the ocean circulations. As you go into century scale, now you have to talk about how the oceans change in their circulation. And is that going on right now that's fooling us, that's just fooling us about what carbon dioxide might be? And that is the real crux, is how can you know the impact of the extra carbon dioxide when Mother Nature is also playing big roles in causing changes? It's very difficult to extract one from the other.
I've seen a research recently with some civil physicists who saw a link between the sun's solar cycle and the La Nina, El Nino. I don't know if you see that paper. They used the 22 years cycle of the sun, and they actually see a link. Is that something you also go into your research, or are you just focusing on the atmosphere?
Well, I've looked just at the last 40 years with our satellite data, and for the stratosphere, way up high in the atmosphere, we see a very strong link between the solar variations and the temperature up there. But down in the troposphere, it's much harder to find just on a 40-year time scale. But on the longer time scales, I have seen some results that show that the variation in the strength of the sunspot cycle, or really the solar irradiated flux that comes into the Earth, does have a relationship with the land surface temperature. And so that's another one of those Mother Nature factors, those natural factors that confuses us when we try to figure out what the carbon dioxide signal is.
There's many factors who play all the time, and they can make each other stronger, and they can make each other weaker. So
yeah, and we cannot forget the factor of internal variability. This is not dealing with the sun or volcanoes or anything, just within the climate system itself. It has the capability to organize itself and create hot periods and cold periods. If you look back through the history of time, you will see that just naturally the climate can have these large variations.
Is that due to the ocean atmosphere connection, or is it the atmosphere layer who plays, or where does it come from?
These kind of variations are primarily, I believe, driven by the ocean circulation and the atmosphere response. But I have to say the atmosphere also has impact on the ocean, so it is a two-way street. You know, why do so many indicators show that the Earth was warmer 1,000 years ago? Especially in many regions, it was just warmer 1,000 years ago than today. The sun really hasn't changed that much in that time period. So what other kind of natural variations would have occurred to create that warm period?
True. You have been involved in the IPCC as a lead author. I can remember a long time ago. Why did you leave that organization?
Oh, well, the IPCC is something you don't leave. The IPCC is something to which you are invited.
Oh.
And I was invited to be a lead author because of the work on the satellite data and other temperature data sets I had built and published on. But since that report, that was the TAR, or the third assessment report, the IPCC has not allowed any skeptical scientists to be part of the authorship team. And so when they say, yes, we have the consensus of scientists, they have the consensus of the scientists they picked. And so if you agree with the consensus, then you get picked to be an author. And so imagine that. You end up with a document that agrees with this consensus.
Yeah. So have you been involved in any of the conclusions?
I have been a reviewer. I volunteered to be a reviewer, but as we found through the last couple of cycles, that they really don't pay attention to reviewer comments if they are skeptical or challenge the views that the IPCC wants to make.
Oh, so it's one-way talk, one-way traffic.
Yeah, now I will say this, that there are some good things about the IPCC. If you go into the very thick document that outlines a lot of the individual results and research efforts, you will find some very good material there. It's in the summary statements that come out that the press feeds on and so on, in which all of that is pretty much ignored, and they just want a dramatic story to tell. Yeah,
breaking news. It seems to me when I see the data that the global temperature has risen from 1980 to around 2000, where it's kind of leveling off, just like in the 1960 era. But CO2 is still climbing as it used to do. Has anyone come up with an explanation for this stagnation of temperature?
You know, the only explanation that really works is the internal natural variability of the climate system. That within the system itself, it can make warmer periods and colder periods happen. The El Niños and La Niñas, those spikes every 1 or 2 years or so that last 1 or 2 years, have pretty much balanced out in the last 40 years. so that you have a trend overall of about almost 1.5 degrees per century, almost that much, and that's much lower than what the climate models have been indicating. They're generally running about 2.5 to 3 degrees per century.
So it's not really like there've been a huge debate about if the rise in CO2 is due to human activity alone. What do you think about that? Is it humans caused all of it?
Well, the humans have certainly caused most of it, and they have some very good information about how that happens. One of the interesting ones is just look at the oxygen level in the atmosphere, and the oxygen level has declined a very tiny bit that matches the increase in CO2, because carbon, when you burn carbon, you oxidize it. So carbon becomes CO2, and you take that oxygen out of the atmosphere. So that's one of the examples that shows that it is almost certainly due to human progress, I should say. People don't go out and burn carbon because they're just bad people. We burn carbon because it helps our lives. It provides the energy that gives us longer and better lives. And more of the world wants to do that, as we see in China and other countries.
And we are kind of a tropical species. We don't thrive very well in cold area. We don't have energy and shelter. So I guess, and we are smart animals. So
yes, we have figured out, climate is dangerous. It's always been dangerous, and we figured out how to make it safe for humans.
There's a reason why not many people live in the Arctic region, and a lot of people live near the equator. So it's much easier.
I tell the story about in the United States, I think I got these numbers right, that over the last 120 years, the temperature has changed about 4 degrees for the average American. 4 degrees. Well, that's because a lot of Americans have moved to the south where it's warmer. So the average American lives in a much warmer climate.
Yeah. Is that due to poverty or something else, or it's easier to thrive in a warmer climate?
Well, I think it's because warmer climates are just much easier to live with. And you can go outside many more days a year and enjoy outdoor activities. If you're a warm person. Now, someone from Wisconsin in the United States says, well, I love ice fishing, and so they like the colder weather, and that's fine.
Yeah. And then they have summer house in Texas.
Yes.
In your point of view, what would be the most important to research within the next 5 to 10 years to better have an understanding of the climate system? What is the missing puzzles we need?
Well, I think there's always work to be done on the observational data sets, especially 100 years ago or so. But I think in terms of the science question is what happens in the atmosphere, in the upper atmosphere, in terms of the moist thermodynamics, or how does water vapor change? How do clouds change? That those are the keys to understanding why in the real world, when the Earth warms up, it releases a lot of heat, but in the model world, it doesn't release that heat and retains it and keeps it hot on the surface.
Is there something we are close to understand, or is still a long time ago before we really have a big picture?
This is that's a very good question, because the same mistake has been going on for 40 years, and you would think that modelers would really make a big effort to try to dial back to reduce that impact, but we just don't see it.
Oh, is that because of the political influence in the science?
That can't be ruled out, that when you have a model that tells a terrible story, you get attention. And so that helps you with future funding and efforts and so on. Also helps you get published, because publishers like to publish scary things because that's what people buy.
Do you think this, I've spoken to a few scientists as you, and they all see this trend that when you want to research something, and if it's a little bit skeptic towards the so-called consensus, it's pretty hard to get funding to this. Do you think this political controls science has threatened the credibility of in the public.
Yes, I think that has happened. That climate science has been corrupted to a large extent. That funding agencies will fund those scientists who are looking at climate problems and how bad the climate can get. They're pretty much unwilling to fund skeptical type questions that people like me ask. We do have some funding, but if you look at the total picture, the amount of funding towards skeptics is well under 5% of what those that are what you call non-skeptics get. So it's a tough road to go up against that kind of money.
Yeah. And I guess that's why you don't see that many skeptical articles being released, because they really don't have the money to it.
Right, to do the research.
Yeah. European Union had just agreed to about a big agreement to lower the CO2 emissions by 2035, I believe, to 70% of the current level. In your point of view, would that make any difference to let's say the whole Europe managed to do that, like lower the emissions? Would that change anything? Would that change the temperature we will be able to measure?
In terms of the climate, there won't be any effect. I actually did the calculation if we completely eliminated the United States from the Earth. Just no people, no cars, nothing. And the impact was very tiny, less than 1/10 of a degree by 2050. So no, it's not going to have an effect, especially when the rest of the world wants to have the energy like we have. They want to have a life that's long and that's prosperous like we have. And so they will be using energy more and more. And so Europe and the United States are not driving the bus on emissions. So we're pretty much out of the picture now.
Yeah. What kind of action should be? Does it have to take for to tip the scale to make an impact? Because 100 parts per million, it seems a very tiny bit of increase. Would it matter if the whole world stopped to work?
You know, I can't imagine that world, but suppose in our imaginations, carbon dioxide would just stopped. That wouldn't have much effect on the climate because there's so much CO2 in the atmosphere already. And so it wouldn't change the curve very much. And the climate would not notice much at all.
No, okay. Actually, most of the policies they make in the US and in the Europe, it doesn't have a much effect or have that effect as they say on the climate system.
Right. These policies, if the climate models are right, and I don't think they are, if the climate models are right and we use these policies you're talking about, the global temperature is going to be affected by hundredths of degrees, not even 1/10 of a degree, because we're still emitting. We're only just taking down our emissions a little bit, with great pain, by the way, and you have to balance that with what kind of suffering are you causing? You know, I lived in Africa, and I can tell you that without energy, life is brutal and short. And so those people, they are people just like us, and they want to have a lifestyle where they can live long and prosper as well. And we are not the people to tell them they can't. And in fact, if you look at the real numbers, they aren't following any of our advice as rich people. They are moving forward with progress for their own people.
And it seems this climate consensus, this worry about the climate is only the Western world, US, maybe Australia, maybe Japan, but it seems like the rest of Asia just really don't care. They just go along and do what they always been, like spending and telling United Nations what they want to hear, and they just keep moving.
Yeah, the way I heard it expressed one time is, when you have food on the table, you can worry about climate change. When you don't have food on the table, you never worry about climate change.
No.
You worry about putting food on the table.
Yeah, exactly. And that's actually in Europe, especially in Denmark and in Germany, we have the highest energy prices in the world due to a huge funding for renewable energy, and the number of energy poverty, especially in Germany, is rising like rocket because more and more people cannot afford to heat their homes. So it has a big effect on even modern society.
Yeah, and you would think that policymakers would understand that if you raise the price of energy, you've just raised the price of everything. And really what you've done is you've been able to create millions of jobs in China and India. So you're working down a system of full employment for Chinese and Southeast Asia and less employment in Europe.
If tomorrow I gave you power to rule the world, you are in charge. If those policies shouldn't be in effect, what would you change if not that big priority in CO2? What would you prioritize instead?
Well, you know, I hadn't thought about being president of the world so that I could initiate policies, but I would roll back the regulations. I would, especially those regulations that benefit the renewables, I would want them to stand on their own, that they produce electricity at a price that people can afford, and let natural gas come into play more. And if renewables can't compete with natural gas, then they should go away. It's just a market economy. That's a free market system. Is whichever is best and most competitive is that which survives. And that's what people want. They want to have the most affordable way to get their demands met. So that's probably the biggest thing. Is I would take a look at all those regulations that benefit renewables when they have had benefits for decades and still cannot produce electricity at the amount and cost that we need.
But many say like fossil fuels, there really isn't, in my point of view, any alternative to fossil fuels, maybe nuclear energy. But eventually it will run out, so we have to think about something in the future, if not nuclear. So, but I guess we can stretch it a little longer if you use like nuclear energy. And
well, here's what I have to say about that. We didn't leave the Stone Age because we ran out of rocks. And we didn't leave the Wood Age because we ran out of trees. It's because something better came along.
Yeah.
We will leave the Carbon Age when something better comes along. And I suppose it's going to be something somewhat like nuclear, because that has huge baseload capability. It can produce lots of power. And it's very small in terms of its area that affects the planet. Whereas these renewables are highly intensive in terms of the amount of area that they use, the minerals that are used to build them, a very environmentally damaging situation. And then the waste that they create is huge and a big problem that we're seeing now. So I think that we will be leaving the Carbon Age this century because we've found better ways to use nuclear, is the way I see it. Is that there will be the types of reactors that can be deployed and built rapidly and provide just continuous power that we can use. So that's kind of the way I see it long into the future.
Yeah, I guess you're right. I don't think I have any more questions. It's been fun to speak to you. Been a pleasure. Thank you for taking your time.
Thank you.
Take care.
Okay.
Bye-bye.
Bye.